Hello, and welcome to Empowered Learning. This video will be about how to take a polynomial in factored form and to sketch a graph of it. So in order to sketch a graph of a polynomial function, there are a few properties about that polynomial that we need to know. The first thing that we need to know is where are its zeros or its x-intercepts. The next thing that we need to know is what is the multiplicity of each zero. And the multiplicity is just how many times each factor repeats. The next thing that we need to know is that multiplicity even or odd? And so we'll note that here. If the multiplicity of a particular zero and thus its corresponding factor is even, so if multiplicity is even, then that means that the graph is tangent to, or like how I like to say, touches or bounces off of the x-axis. So you'll have something that looks like this or something that looks like this. Okay? If the multiplicity is odd, then the function will cross through the x-axis either like this or like this on the x-axis there. Okay? So that is what even and odd multiplicity means. And so how I'm going to do it is I'm going to ask, because of that, we'll say it crosses through here. I'm just going to simply put a column here that says cross or touch, like that. And so once we have all that information, the last thing that we need to know is what is the leading coefficient, which we're calling a sub n. And I'm saying that because we could rewrite our polynomial in this form. Where the a sub n is just the coefficient that is outside, or the greatest common factor between all these. And we see that our corresponding factors are x minus the first 0, which is R1, the second R2, second R3, so on and so forth. So we need to know that. And we also need to know the degree of the polynomial. And of course, we need to know that because degree of the polynomial and the leading coefficient of the polynomial together give us what we call the end behavior. And so we'll talk more about that once we get the rest of this list down here. All right, so looking at the zeros, we see that we have a factor of x here. So the number that we would plug in for x here to make everything go to 0 is 0. So that is our 0 or x-intercept there. We also have another 0 at 4, because we know 4 minus 4 will give us 0. We also have another 0 at -1, and we have another one at 6. Okay? And so what I'm going to do is I'm going to rewrite these in order so that we can use that to actually graph our polynomial later. So -1 is our smallest number. Then after that we have 0. Then after that we have 4. And then after that we have 6. So I'm just going to rewrite it that way. Okay. So now that we know what our corresponding zeros are, and of course -1 corresponds to the factor x plus 1, 0 corresponds to the factor x, and 4 corresponds to the factor x minus 4, 6 corresponds to the factor x minus 6. And so if you notice, for each of these, all these factors only repeat once, so it is like we have a understood 1 as an exponent for all of these. So that means in this case the multiplicity of each of these particular zeros and their corresponding factors is 1. And since technically we'll call 1 an odd number in this case, they will all cross through the x-axis at those particular x value locations. Now, we need to know what the leading term is. And so since we don't see anything here, it is an understood 1 that is right there. So we know that our leading term is 1. For our degree, that's easy to find because all we need to do is add up the multiplicities. So if we add up all of the exponents of each factor, we see that that ends up being 4, and that is what our degree is. And so now the last thing that we need to do is we need to decipher what our end behavior is going to be from our leading coefficient and degree. And of course, in this case, we know that our leading coefficient is 1, and we know that our degree is 4. So simply put, whenever we have polynomials and we deal with their end behavior, they only have 4 choices. So choice number 1 is something like this, and this is the case of when the leading coefficient is positive and the degree is even, and that's kind of what we see here. So to me, I like to say whenever we have this, our end behavior looks a lot like x squared, okay? And we know x squared kind of looks like a parabola like that. The other case is like this, where our leading coefficient is negative and our degree is still even, okay? Now, the other choices that we have, I'm going to just move down here, is we can have a case where we have something that looks like a positive x cubed, which looks like this. And in this case, our leading coefficient is positive, but our degree is odd. So let's say if our degree was 3 instead of 4. And then you have the case here where this looks like a negative x cubed. And in this case, we know that our leading coefficient is negative, but n is odd. And so for this one, since our leading coefficient is positive and our degree is even, we know that we're going to have end behavior that looks like this one right here. So I'm going to take this information and move it over here, just so that we don't lose that. And when we come here to draw everything, first thing that we want to note is we're going to have end behavior that looks like this. Okay. Now, when we go back to our original table here, we know that we have zeros at -1, 0, 4, and 6. So we're going to locate those places. So at x equals -1, at x equals 0, at 1, 2, 3, at x equals 4, and at x equals 6. And when we look at all these, we see that since the multiplicity is 1 for all of them, which means that the graph will cross through the x-axis, then if we start from up here and noting that a polynomial function must always be continuous, the only choice for our first 0 here, which is at x equals -1, is to cross through like that. Our second is to cross through like this. Our third is to cross through like that. And the fourth is to cross through like that. So if we kind of look at this, we'll see that it'll have sort of this W looking type shape here. So if we draw all this out, this will look something like this. And so I'm using a different color here. So we'll come here, cross, go up, come up like this, go down, up again, and then connect right there. So our graph will look something like that. Now, of course, we don't know how high this goes, and we don't know how low those dips go. And so that's actually something that's reserved for whenever you go into pre-calculus or calculus to figure out how high that goes and how high this peak goes and how low those dips go. Okay, but for context of what we're doing now, all we need to understand is just a general profile or a general sketch of what the graph looks like. And so again, this is how we figure that out. We just look at the polynomial in factored form. We pick out its zeros. We identify the multiplicity of each factor. And depending upon whether the exponent of each factor is even or odd, tells us whether it is crossing through the x-axis or it is tangent to, or how I like to nickname, just touches. And then from there, of course, the sum of the multiplicities gives us the degree. The leading coefficient in factor form is always the number that is out here. And of course, looking at the combination of whether the leading coefficient is positive or negative, and if the degree is even or odd, we have one of these four choices. First choice is like a positive x squared. Second choice is like a negative x squared. Third choice is like a positive x cubed. And fourth choice is like a negative x cubed. Okay, so now we'll go ahead and move on to another example. Okay, so in our second example here, we see that we have f of x is equal to negative 3 times x minus 4 raised to the 2 times x minus 6 times x plus 2 raised to the 3. And so here, trying to do this in order, we see that the x plus 2 here has an associated 0 of negative 2, because negative 2 plus 2 gives you 0. And then here, if we plugged in the 4 right here, 4 minus 4 will make everything go to 0. So that's the next one. And then, of course, 6 minus 6 here will make everything go to 0. So we know that negative 2, 4, and 6 are our corresponding zeros. Now, for the multiplicity, we see that for the corresponding factor where x is negative 2 for 0 is here, and the exponent on that is 3. For the factor with, that is associated with the 0 of x equals 4, we see that that exponent is 2. And of course, for the 0 x equals 6, there's an understood 1 there, so the multiplicity of that is 1. Now, we know that whenever the multiplicity is odd, it has to cross through the x-axis, and whenever it's even, it has to touch or be tangent to. So we kind of know what it's going to look like at each of these zeros here. So I'm going to go ahead now, before I figure out the rest of this, and identify where my zeros are. So at negative 2, at 4, and I believe at 6, if I have that correct there. Let's look back up, yes. Those are where our zeros are at. Now, we don't want to start trying to draw whether it crosses or touches through until we figure out what the end behavior is. So we know in order to find the end behavior, we need to know the leading coefficient and the degree. Well, the leading coefficient is easy because it's right here. It is a negative 3. And for our degree, we just add up some of the multiplicities here. So 3 plus 2 is 5, 5 plus 1 is 6. Okay? And so we see here in this case, we have a situation where the leading coefficient is negative, but again, the degree is even, so it's going to look like a negative x cubed, which is going to look like this. And so when we come to our graph here, we know that we're going to have some end behavior that's going to be like this over here and like that over there. And so now we can go back up and tell about the, from the multiplicity, you see where it crosses or touches. So at negative 2, we know it's going to cross. At 4, we know it's going to touch or bounce off of the x-axis. And then at 6, is going to cross again. Okay, so let's go back here. We know here it's going to cross. And right here, it's after it comes up, it's going to touch or bounce off of the x-axis. So it's going to look like that. And then, of course, for this last one here, it has to cross again. Okay. And so if we were sketching a graph of this, it would look something like this. So we would start down here. The graph would kind of go like this, come up, bounce off, come up, go back down, and look like that. Okay. And of course, if we wanted to get a little bit more specific, we could indeed figure out where the y-intercept is by just plugging in 0 for all these values of x here. You'll quickly find out that that would actually end up being a somewhat large number there. So we really wouldn't want to worry about that right now. But the main thing is that you understand the basic profile of the graph, which would look something like this. Okay. The only other thing that I want to add here is, since we know that at x equals -2 at that particular 0, since this is of multiplicity 3, it does cross through like how you see here, but since it's raised to the third power, it takes more of the shape of x cubed. And so that's actually something that you'll learn, for those of you that end up having to take calculus, you'll learn that then. But just want to go ahead and let you know that now, that whenever you just have a factor of just x raised to the 1, it actually crosses through like a line. But whenever you have something like x cubed, it'll cross through like that. And so I'm just going to come here and erase this part here and kind of redraw it so that you can see truly what it ends up looking like. So we have the 0 here, and I'll erase some more of this to make it look okay. But this will actually kind of do something like this. It'll come through and kind of do like that. And of course down here it'll connect. So that is actually how it will look. But for what we're doing here conceptually, just making it cross through will suffice as an acceptable answer. Okay? So this is 2 examples of how to take a polynomial that is in factored form and use the properties of that polynomial in factored form to be able to sketch a graph of it. And so I hope this video helped, and check out my other videos if you have a chance. Take care.